Hi everyone, Mrs. Besega here, and now we're working on relationships and equations. In the previous video, we looked at how to graph using Physics Aviary Quick Graph 5.0, how to add a trend line, and how to turn that trend line into a relationship. Now we're going to break down the main relationships you need to know for physics. So, from Physics Aviary, you should have seen these 10 relationships. Luckily for us, 2 of them are just not going to be used right now. Inverse square root doesn't show up in any of the physics we do, and exponential won't show up until at least April. So feel free to not include those as you take notes right now. And I suggest as you're taking notes, you should pause this video. Pause this video with the screen right here. Grab a piece of paper wherever it is you're taking notes. It's probably hard to simultaneously take notes on your iPad while watching this video on your iPad, so I do suggest having a notebook for this. Break it up into 4 columns, 9 rows with that title on top, so that you've got all of these at your disposal for our activity that comes next. Okay, so pause it. Copy this. Leave yourself some space because you're going to draw a sketch, right? So here are the main relationships you need to know in our class soon. The first is a directly proportional relationship. This is the type of relationship that's super easy to work with because it means that if x doubles, y doubles. 1 to 1, super easy. You'll notice that this is a linear relationship that goes through the origin. That's the difference between a direct relationship and the one that comes next. In this example, that means y is pressure, x is temperature, so P is proportional to T. This symbol right here that I use is meaning proportional. There might be some other numbers here, like the slope is clearly there, but I'm going to leave those out for now. 2 is a linear relationship. A linear relationship still has a slope, could be positive or negative, but notice that a linear relationship does not go through the origin, and therefore I can make no proportionality statement about it. Obviously, this is in the form y equals mx plus b, but when I write the proportionality equation, for this, I'm just going to, for now, leave out the slope and leave out the y-intercept. So in this case, y is still proportional to x. In this case, velocity is on the y-axis, so v is proportional to t. Next, a squared relationship. This means if x triples, then y becomes 3 squared, or 9 times larger. In this case, y is proportional to x squared, or PE is proportional to, hey, still x squared because x is on the x-axis. Cubic relationships. If x triples, y is 3 cubed, or 27 times larger. You should know the equation for this, but please keep in mind that in physics, you're not going to see this come up pretty much at all. But square root, I promise you will see some square root functions. Square root functions means that if x quadruples, then y only doubles. It doesn't straight do the same thing. If y triples, if x triples, y doesn't triple. So how to check this? Next up is a square root relationship. This is the type of relationship that x increases still causes an increase in y, but not quite as drastic. So in this case, if x quadruples from, say, 500 to 2000, then, well, y doesn't exactly quadruple. It less than quadruples. It just doubles. How to check is take y is proportional to the square root of x. In this case, on the y-axis is time, so t is proportional to square root of length, because length is on the x-axis. 6. Another great easy one. If there's no relationship, you get this nice horizontal line here, slope of 0. And what that means is that whatever x does, it could triple, quadruple, nonuple, which means times 9. That's a great word, nonuple. No matter what you do to x, y doesn't change. Y stays exactly the same in this graph. An inverse relationship, like from point A to point B, means that if x doubles, y is halved. Inverse relationship means if one variable goes up, the other decreases. You're going to see me do this hand motion a lot. The equation is y is equal to, or is proportional to, 1 over x. And in this example, it's very hard to read, my bad here. That's pressure on the y-axis, so pressure replaces y, that's P, is proportional to 1 divided by volume. And the last one. Guys, you're going to see this one come up starting in quarter 2, probably, depending on our schedule. Starting on quarter 2, because inverse squares occur with fields and waves that spread out in 3 dimensions. So when we get to gravity, light, sound, radiation, all of those will have relationships like inverse square. No big worries about this right this second. An inverse square means that if one variable, if x doubles, then y decreases, but much more drastically than an inverse. In an inverse, if x doubles, like the volume goes from 1 to 2, then the pressure gets cut in half. It goes from 3 to about 1.5. An inverse square is more drastic. Notice that if I make the radius go from 1 to 2, that relative intensity, this is for light by the way, if you get twice as far away from a light source, it actually becomes 4 times dimmer because of how that light spreads out over space. So equation for this one is y is proportional to 1 over x squared. So what I would like us to do is let's review, recap all of our relationships. At this point in your notes, you should have 8 relationships down. Number 2, linear, doesn't have a proportionality statement because it doesn't have a y-intercept at 0. No relationship has no equation and no proportions, but the rest should be filled out at this point. If you don't have it done, feel free to rewind, recap this video, or chat with the other people in your group and maybe they can send you the thing that you're missing. Okay? So make sure you've got this before you move on to the next thing. Good luck!